Okay, can you hear me? So I'm Pietro BONFA from CIENCA. As you may have understood, Carlo Cavazzoni unfortunately couldn't be here today, but he was kind enough to give me some of his slides. So I will now give a short introduction to Marconi, which is the tier 0 system of CIENCA. So, okay, perfect. So Marconi is mainly used for scientific research. At the moment, about 70% of the CPU time is used for European scientific projects, and mainly through the PRAISE and the Eurofusion agreements. Then there is a remaining 30% of the time which is instead used for the Italian scientific community with programs for national researchers and also local researchers. So this is a regional-based program. Then there are other allocations which are discussed directly with national and international institutions like ICTP or INFN. But let's go immediately to the technical details that are probably more interesting for you. So, at the time being, Marconi is made up of 3 partitions that share the same file system. So, of course, parallel GPFS file system. So the 3 partitions are the partition A1, installed in April 2016, and it's 1,500, about 1,500 Lenovo NetScale servers that have Intel Broadwell cores, so with 2 sockets, 18 cores per socket, running at 2.3 GHz frequency, and there is 128 gigabytes DDR4 memory. So this partition amounts to about 700 kilowatt. The next partition that has been installed arrived in September 2016, and this what I will be focusing in this presentation, in the next presentation, is the 3,600 Intel Atom Pass servers that are equipped with Intel Phi Knights Landing, the version with 68 cores and 1.4 gigahertz Atom cores. So the single socket node has 96 gigabytes of memory and 16 gigabytes of high bandwidth MCD RAM. And finally now, it really started a few months ago, there is an A3 partition right now available for the Eurofusion project, and still we don't have the whole 2,300 nodes, but a subset of this. This is a Skylake based partition with 2 sockets having 24 cores each, and running at 2.1 gigahertz with 192 gigabytes of DDR4. And this partition is has more or less the same power consumption as this partition will have. Actually, it doesn't have now, but will have more or less the same power consumption of the A2 partition. So, for what concerns the network, all these building blocks are connected with an custom Intel Omnipath network that can go up to 100 gigabits per second. And this was, well, actually, I don't know, I'm not sure it still is the largest Omnipath cluster in the world. And the topology is reported here. So there is a FAT3 topology with 201 oversubscription and a tapering that happens only at core switches. So if you do the math, the total number, the maximum number of servers that you can connect with this FAT3 topology is 7,068 servers. Well, this is reported here in block diagrams. So this is how the topology is implemented. And what we actually have is 32 nodes that constitute the fully interconnected islands in which the whole partition is divided. So this is the current configuration, but some changes will be done in the next future. So at the moment we are completing the installation and the production phase of partition A3. And when this will be done, the partition A1 will be shrinked. So the 1,500 nodes will, so only 720 nodes will remain in the so-called partition A1 OPA, which means omnipath, because most of these nodes, or let's say all of the other remaining nodes, will constitute the ETH partition. So there has been a great interest in going through virtual or container-based access to scientific computing. So we really are answering these needs to have customized environments for scientific computation with a new partition that will be available soon, probably already next year, which has a low, a smaller interconnection bandwidth, and is supposed to be used in a totally different manner, mainly with Docker containers, which are already implemented and let's say explored in Marconi right now, and with the standard virtual machine system. So this is how the new Marconi, the final version of Marconi will be. This is a block diagram that represents all the old Marconi A1 and through A1, A2, and A3 partition, as well as the new Ethernet connection based Marconi A1. So there will be, of course, new GPFS storage servers to allocate the space for containers and virtual machines that are, of course, that require larger disk space availability, and of course also increase upgrades in the tape drivers, and well, all of these will be accessed through shared file systems between Marconi A1 and Marconi OPA. So let me go now, let me focus now a little bit on Marconi A2. I am very curious to know what were the problems we have had. We did many improvements, also with some system settings, and now I believe that Marconi A2 is in a stable production phase. We'll see what went wrong. What I want to show here is that it took quite some time to decide what was the best configuration for sub-NUMA clustering and high bandwidth memory. So for what concerns sub-NUMA clustering, the opportunity to do sub-NUMA clustering, well, the indications from Intel were choose quadrants. So not sure if this is consistent with what we heard this morning, but I think that this is working great, so no problem here. Instead, we had to decide whether to have whole nodes in cache mode or in flat mode, a portion of them, and the remaining part in cache mode. So the decision was made following more or less this point in order of importance. So of course cache mode is easier for users, it was already said, and since scientific users just want to run the code, it was an important point. Then, as I told at the beginning, PRAISE is a European project for large, I would say massively parallel programs and applications. So having a larger set of nodes for the parallel execution was better. So this was the main point that allowed us to choose the all nodes in cache mode configuration that we have now, apart from a few testing nodes in flat mode. Well, and finally, something that has been discussed before, most used applications, and I have a picture here about, well, these are actually the most used application on Galileo, but more or less the same is observed also on Marconi. Most used application didn't lose too much using cache mode instead of flat mode, and I think that this has been also discussed before. So a few things that are probably trivial for you, for most of you in this room, but are absolutely not known to the users. Well, apart from this thing, we obtain the best results disabling the turbo mode and leaving all the KNL cores at maximum frequency fixed. But the other 2 points here are quite important. So GPFS, as you know, eats a lot of memory. So users have been warned about the fact that you can actually allocate 90 gigabytes of memory, but you can do swapping depending on the GPFS memory consumption. And so a safety setting is using 86 gigabytes in cache mode, which means more or less always, apart from the few test nodes. And otherwise, of course, you observe tremendous slowdowns. But this is another very important point. We found that in most of the applications that we benchmarked, we had to leave some cores idle, in a sense. So leave a few cores for MPI communication, the operating system in general. At the beginning, we also had problems with GPFS, so like was running on one core intensively. So, but apart from GPFS problems, this seems to be a winning strategy for obtaining the best performances. And you can have slowdowns also a factor 2 if you don't do this for some specific applications. And by the way, it seems to be also the best approach on Skylake. So we have just moved the first steps with Skylake, and it looks like for some application, also in this case, leaving some cores for system, operating system and MPI communication is a better approach. Okay, so finally, let me do a short detour. This is a PCP machine that is coming to CIENCA soon, and it's very similar to the one that you were already introduced. So open power, CPUs, processor, and most of the computational power of the teraflop are coming from 4 P100 installed in each node. So I'm telling you this also in view of the presentation that I'm going to do after this one. So it's a total change of paradigm where most of the flops come from the GPUs instead of the CPUs. And it's something that is, of course, the idea of accelerators taking momentum. So it's something to keep in mind. Okay, so having said that, I think I'm done for this first part. Thank you for the attention. I think we can answer questions for this part now, and then I move to the second part and I collect other questions later.